Hi, I'm Clara and I'm from Montrose High School.
And I'm Caroline from Montrose High School.
So we worked at CU Boulder in the new aerospace engineering building. We were under Scott Palo, but our mentor was named Andrew DeHeer. So here are our projects. Caroline and I worked on the Maxwell CubeSats, which is about a 12 by 6 inch satellite, which is very compact and which is created to how would I word it? Which is created for universities to create satellites. Here is the shell of the satellite that we had since it was currently being built at the Air Force Academy. So my project was I was supposed to create an interface plate that would go on top of the QB50 Challenger TVAC mounting plate. So QB50 Challenger was the previous CubeSat that was created at CU Boulder. So here's some background on my project. We needed an interface plate that would be able to fit into a TVAC chamber, which is this thing. However, we did not get a picture from ours in the lab. The reason satellites are placed inside a TVAC chamber is in order to test the conditions and durability of a thermal vacuum chamber in order to see if the Maxwell CubeSat would be able to resist the atmospheric pressure and heat when it would leave our atmosphere and the cold conditions in space. So my original design was this thing. It was very complicated and it took a lot of work. What no one really likes to talk about is how much tutorials I had to go through in order to learn how to use the computer program SolidWorks. So once I talked to my mentor, we redesigned it and made it a lot simpler. So the problem was there was a photodiode window, so it was an obtrusion within the satellite itself, and we had to find a way to create a window in order for it to be able to go in the mounting plate but not be broken by it. And another problem here was I did not account for errors originally. So this is a photodiode I was talking about, and so the problem is if it sits on top of this, it would have broken without the window. So after I redesigned it, I took into account errors, margins of errors, and I also had to rise it by the 10th of a thousand in order to account for thermal conductivity. And here are some modifications. The photodiode window was made larger, and it was also rounded at the corners since it's a lot more expensive to create sharp edges than it is to make one rounder. And here is the final project that I created since I was not able to machine the part because at the new building they drilled through the power supply, so I couldn't create it myself in the shop.
So my project was working with ADCS sensors. That's the altitude determination and control of the satellite. So I basically worked with two different types of gyroscopes. In this project, there were shuttle boards and breakout boards. My kind of job was determining which ones would perform the best and kind of figuring out the code to connect that with our computer to test that. So this is the experiment I came up with to test the X, Y, and Z axis of each gyroscope. Those three in the picture were the ones that I was testing. And what would happen is I would plug them into the Arduino, which was connected to the computer, and I rotated them twice on that turntable, and then the graphs resulted. You can go to the next slide. The graphs, the purpose of these was to figure out which was the most precise and accurate, so we wanted to get a flat line because they were moving at a constant rate. So you can see some of them were not as accurate as the other ones. This z-axis on our last gyroscope was actually the best because it has a very constant rate for the axis as it was turning around the turntable. The other ones were not super accurate, so you're kind of trying to figure out which one would be best to determine the position of the satellite.
Our adventures in Boulder. So this is Ralphie, the CU Boulder mascot, and we determined and were told that she is in fact a girl. We spent most of our time in the CU library, and it's beautiful. And it also has a bunch of galleries, and they sell the projects in order to pay for some of the books. And here's the last building, which is near the new aerospace building.
We also spent a lot of our free time on Pearl Street, so if you've ever been to Boulder, you know that that's a super exciting place with a lot of really cool shops and attractions. There were a lot of street performers. Some were definitely more interesting than others. We also went to a lot of farmers markets, but they were too expensive for us, so we didn't really buy anything.
Another one of our adventures was we went down to Golden Hill, which is one of the oldest mining towns in Colorado. Our host family is dressed in beekeeper suits, and they have their two small children, Shay and Quinn. We also, almost every day, we had tea, and this was at the Dushanbe Tea House, one of the most exquisite places I've ever seen. So our advice to others is when faced with challenges, focus on a solution instead of the challenge itself. The reason we say this is because we had complicated housing situations where we also needed to find a direct route to our university since we did not take a car, we biked. And at the end, we biked around 226 miles each. Thank you.